We'll use exactly the same circuit here. The only variation which we'll make here is we'll make this also NMOSes, right? And the same functionality can be achieved. Let's first draw it real quick. So two NMOSes connected back to back. Let's call it a read enable. Exactly the same way of functioning. This is the read enable for this bottom one. I'm teaching you how to remember. This is my bit. We will see what this is very shortly. Remember this. And these are cross coupled inverters. This is VDD, correct? This will go here. This is ground, and the same connections exactly goes here. This, let's call it as X. X is given as the input here. This will get connected here. Let's call it this Y. So Y will get connected as an input here. I'm not shorting it. It's the same connection exactly. What we need to understand is whether the difference is sensed or not. Let's quickly go ahead and see that. So let's presume bit was at VDD by 2, and this point, which we'll call it very shortly what it is called, is VDD by 2 plus delta V. We have just seen that when read enable goes to 1, these both transistors are on, and so is this. So this node gets VDD by 2, let's say is 0.9. If I'm assuming my VDD to be as 1.8, if I'm assuming my VDD to be as 5 volts, VDD by 2 is going to be 2.5 volts. So this will be 0.9, this will be 0.9 plus something, and then the sense amplifier will amplify the difference which we have already seen, correct? So now let's go ahead and make this entire array connection, and let's understand how a DRAM is operating. So we have seen the pre-charge for DRAM, we have seen the 1-bit DRAM, we have also seen the sense amplifier for DRAM. Let's make all these connections for one column of DRAM. Let's make one column of DRAM. So this is one column of DRAM. Suppose it has 128 cells. What does it mean is, this is one column, right? So it will have 128 locations. What I'm going to do is I'm going to split this into two parts. Upper part would have 64 and lower part will have 64. Let's do that splitting. I'm not going to draw all of them. I'm going to draw a couple of them. So this is my first DRAM, correct? This is my second DRAM. And I'm going to draw one more. This is my third DRAM, correct? And they're all in the same column. So we can short all of this. They are all connected to output, correct? This is my bit line. That's the reason we said that C bit is a very high value. This is my word line 1, word line 2, word line 3. So these are upper 64 cells, and like this we'll have a lot more. Fair? Let's draw the lower ones as well, exactly the same. The lower 64. So again, this is bit. This will be different word line, say word line, just for understanding, let's say 65th. One more cell in this column, word line 66th. One more, word line 67, and all of them are also shorted because this terminal is shorted to ground, just for understanding. So you know that the bit line is connected to the pre-charge circuit. So let's quickly go ahead and make a pre-charge circuit here. So this is nothing but PC or phi, and this is nothing but VDD by 2, or we can call it as a voltage, pre-charge voltage as VP. Same for the lower as well. So PC, phi, VDD by 2 or VP, correct? Now we'll put our sense amplifier here. Let's quickly go ahead and put that. So this is how it is. This will go to this terminal of my sense amplifier, and this will go to this terminal of sense amplifier, and then we'll see what's going to happen. Here again there are dot dots, so different cells are present. Now I'm going to put my sense amplifier here, so don't get confused. I'm putting it here, and then we'll make the connections. So these are my two NMOSes. These are my inverters, which are cross coupled. I'm going to make it a bit far so that I can make the connections. This is my bottom NMOS, exactly replicating this circuit. This is ground, read enable, again read enable, correct? Let's call this point as A, just for shorting the connections, and this point as B. So the sense amplifier is connected to bit, and the bit of the lower one and the bit of the upper one. So this is going to be my A, this is going to be my B, correct? Yes. Let's complete the inverter. This is my VDD, correct? The output of this inverter is going to be connected here. The output of this inverter is going to be connected here. And now, very simple, they are cross coupled. So this output will go at this input and this output goes at this input. Exactly the same circuit has been drawn.